Simon is joining us.
Yeah, there we go.
Excellent.
Yep.
I could hear him, but he could
I
not.
was muted beforehand. Yes, I've turned my camera off because the camera pops up on the screen right in front of what I actually need to work with. We're doing just looking at just an introduction to manipulating FLDs. There's a lot more that can be done with these things, but in the time given, this is just a quick introduction. What I'll do is I'll just bring up a base station and put it in onto the map. Yeah, it's two of them there. There's actually no need to import them onto the map, but it might be useful to at least have them sitting there. Right, there they are at the top end of the screen. Now what I've got here is I've got two. I'm just going to do a very simple comparison between the two sites. One of them is operating or transmitting 12 meters off the ground, and the other one at 25 meters off the ground. The idea being just to get an idea of any kind of an enhancement that could be got from these, just lifting the base stations up a bit. Obviously, you can. This is where I find that I don't have the coverages. Never mind, I have them stored. If let's, for instance, we shall load an FLD file for the 25 meter site. So this is the coverage. That's the coverage for the site where the base station is 25 meters off the ground. This is at I think 22 gigs, which is why it's like this. This is effectively a 22 gig microwave link with an omnidirectional antenna, which is the way that the easiest way to plan these things when you start. What I'll do now is, if for instance, we'll start by explaining how to make an FLD file. Let's say I've created a coverage plot for this, and this is the displayed coverage plot. You can just file, save coverage file as an FLD, and that will save whatever coverage is there. It could be one base station's coverage, two base stations coverage, whole network. You can save the whole lot as one FLD file. It's an internal file format used for storing coverage plots of radio sites. Very similar to let's say a Google Earth KML file. Very similar sort of thing, but this is internally for use within RCS Telecom. So this is the coverage originally produced for this site at 25 meters. What we want to do is to find out whether that's any better than the one at 12.5 meters. So what I'm going to do, I don't knock anything over, is load the 12.5 meter. And what you do is you, let's say, we don't want to replace the result in the memory. If I clicked OK now, all that would happen is that the 12.5 meter high base station coverage would be there and the 25 would disappear. But what we want to do is to say let's just say if A, it's not really FA, what we're going to do is we're going to display coverage A, which is the first one that's not being shown at the moment, minus B, and show the results. So what we're doing is we're now looking at the difference between the two coverage plots. And there's the difference between the two coverage plots. So for instance, you changed the antenna, or you had, in this case, we've lifted the base station up a bit. So what this is the difference. In areas like this, there is no difference. What I'll do is I'll just put this thing on. So in areas like this, there's no difference at all. Now that could be due to the it could be due to the fact that there's no coverage there anyway, or it could be that it's line of sight. That's the thing to understand about this plot, is it's where lifting the antenna makes a difference, not whether or not it actually improves things or not. So in this area here, we have a definite advantage. So lifting the antenna up. So it's talking in the office. So in that area there, you have a definite improvement, and just down here as well, there's an improvement. So we'll go back there. So there's an improvement in coverage by lifting it up, but that's all. I'm just going to have to try and remove something from the screen. Is this actually visible? Okay. Right. So. Oh, right. Can you hear me now? Not at all, at all. Hang on a minute.
Just while we get the audio sorted.
Yeah, there's definitely audio coming out at this end. Do you want me to change headphones? No, that's not going to make a difference.
Just a quick vote. Can anyone hear Simon? Can you put your hands up if you can hear Simon? Simon.
How are you connected? Dialed in? Or?
What I'll do is I'll just swap headsets.
I'm just going to swap
See if that makes any
headsets here,
difference.
and Simon will come in on a different line. Please go with us, guys.
Sarah, am I audible again?
You're back with us, thank you.
I'm back. Okay. Right. Actually, an instruction manual for this, so I don't really know why that didn't come up. But I'll put the instructions in later on. It's probably just got the wrong page number on it. But anyway, normally that would work. But you can see from here there are various things to do. This is just quite simply taking one from another. But you can display if it's improved or not improved, or you can take two separate coverage plots for different base stations and display the differences between them. It's a little bit better than doing a best server plot for a lot of these sort of things. Anyway, that's sort of a quick introduction to it. But it is basically a case of save the FLD files from file save FLD. So you save all the different files you wish to use, and then you load them back in again. And you start with, well, it doesn't really matter how you do it, because this for instance is a difference plot, so you could do one or the other. But you load them in, and as you load them in, the first one comes in normally, and the second one asks you to either replace the results or do some manipulation for it. But it's relatively simple to do, but sometimes difficult to decide how to interpret what you've got. Anyway, I think that about covers it as far as an introduction is concerned anyway, but we'll circulate some more detailed documentation about that later on.
That's great, thanks for that, Simon. Does anyone have any questions before we move on to the next subject? If you want to put your hands up, I can unmute you, or you can use the toolbar. Okay, I think we've got no further questions on that. Simon, if we could now move on to the next questions, that's creating a DTM in ICS Telecom.
Okay, just one moment. I've changed headsets, but obviously I haven't changed the headset I'm using for hearing audio, which is a bit difficult because I can't hear what you're saying. Just a moment. Okay, that'll be better. Right, well, could you say that again? I could see your mouth moving. DTMs. Okay, so what I'll do is I'll just change projects for the time being. Right, this is importing DTMs into telecom. It's not yet as comprehensive as Map Server is, but the functionality is slowly becoming more comprehensive. So what I'll do is I'll just show a quick demonstration of how it's done just on a simple LiDAR plot, and then you can perhaps follow that. And again, there are detailed instructions for this because I've seen them. So let's just say here's a project, just a little local project, and I want to change to another little local project somewhere else, but I need to import the terrain for it first. So what you do is you just convert the terrain from, in this case we're going to convert it from ASCII grid and convert it into a geo file, which is an uncompressed terrain database for the ATDI tools. And I do have a couple of maps floating about, and what we'll do is we'll take that one. This is just an ASCII grid file. If I open it up, it's a text-based bitmap format. So here we have a number of columns, so it's 1,000 columns by 1,000 rows, and these are the X and Y coordinates for the one corner, and it tells you that the cell size is 1. So these coordinates are actually in meters. So this is actually United Kingdom National Grid, Ordnance Survey National Grid. So that's the reference point. So we're 5,000 or 529,000 meters across and 205,000 meters up from the reference point for this grid system. And the cell size is 1 because it's 1 meter LiDAR data. And the no data value is -999, and you can actually see that if you go down into the file. There'll probably be some -999s in here, which usually means water, or they just didn't take the data at that point. It's either a no data or water, something like that. All right, let's just close that. So we'll just open that. We're going to save it as that file name, but you can choose whatever you want. I'll replace it. Now this is important. You have to know the coordinate code of an ASCII grid file. If you don't choose the correct CRS, coordinate reference system, you can end up in strange places. Yesterday, while testing this to make sure I'd got it right, I used EPSG in there, which is a European WGS84 based standard, and I ended up with some very interesting terrain, very rocky terrain, turning up on this overlay map. And it took me a little while to realize that I was actually looking at a terrain map for Mars. So ICS Telecom isn't just global, it'll work anywhere in the solar system and beyond. So anyway, we've got the correct grid reference system there for NGR. So right, it's converted it. So what I have to do now is load it. So what I'm going to do is go back to the project manager, load it into this project, overwrite the existing project, and there we are. There's the map that it's picked up automatically. And if I go to the display for the DEM layer, that is the new terrain data. And there's, you can see the fields and a pond, which actually has been filled in, which is very convenient of it, and a street with a row of houses and an industrial estate of some sort. And you can, of course, now start the project. We can add a station there. Oh, that'll probably have to do. Yep. This is, because this is LiDAR data, it's actually treating everything, buildings, trees, as terrain, which is why you can see it like that. And these ridges are because the vertical step in telecom and most planning tools when you're working at these sort of magnification levels is 1 meter. So those are effectively 1 meter contours. But we can now do a quick plot. I'll do a visibility coverage because it's faster. Height to receive antennas 1.5. So that's sort of, you would normally use this sort of LiDAR data if you were doing a microwave distribution system or something like that. So that tells you that from this particular point, all the purple areas, as long as you've got a pole or a stub mast 1.5 meters above the roof line of your building. So for instance on here, you'd be able to see this site, line of sight. It's obviously not doing accurate path profiling, but it's a line of sight plot, and it's a very quick way to work it out. And you could then normally if you were doing this sort of thing, you'd have a subscriber here already, so you would just run a profile back to it. And this is at 400 megs, this thing, this site. So yeah, microwave it would work. There's a bit of Fresnel zone intrusion there, but that doesn't really matter too much considering the frequencies being involved. So yes, that is how you convert. And if you go back into this thing, convert, you've got various other things you can do. You can take a grid ASCII, like a LiDAR plot of something, or drawings, convert them into a building layer. And there's various pictures and various other things that can be converted. It is actually possible here at the moment to create a blank matrix. This is to put multiple LiDAR or multiple tiles into to make a bigger map. At the moment, all you can do is create the blank matrix. You can't yet. I'm telling you this because you might have well have seen this. At the moment, you can't do anything more than create the matrix. We haven't got as far as porting across the functionality from Map Server to actually populate the matrix with tiles. So don't ask about it. It's yet to come. Anyway, yes. So that's a simple example of how to quickly bring in a piece of data and do some work with it.
Okay, that's lovely. Thanks, Simon. Do we have any questions? Either put your hands up and you can put the question directly to Simon, or you can use the toolbar. So that's any questions on creating DTMs. Okay, don't think we've got any further. So if you do think of something, you can always pick it up at the end. We will have time for questions and answers then. Okay, we're going to move on to the next one, which is interference reduction factor and net filter discrimination.
Okay. Right, well, this is another one of those subjects where there are manuals, and there are an awful lot of manuals, and it's quite an involved subject. So what I won't do is go into it in any great detail. I'll just explain roughly how it's done and then point out a couple of the pitfalls that there might be. This is, hang on a minute, I'll just get rid of that coverage. This is a small piece of Somerset in England, quite flat with a couple of little hills at the top. So what I'll do is I'll just bring in, again, bring in my two little base stations. In fact, I'll bring in these three fellas instead. Let's hope this time I've imported the coverages for them. Oh, there's one with coverage anyway. Let's just create some coverages while I'm talking. We'll need them. So when you, effectively IRFs are ways of dealing with stations or other stations in the band that you're operating that may be either adjacent channel or next adjacent channel, or might be wider than the emission that you're using, and they may impinge on part of your passband or all of it. ETSI back in the day used to refer to them as wanted to unwanted ratios, and there used to be WU tables in their standards. It's been a long time since I've looked at one, but I suspect they're probably still there. I'll just do another coverage on this one as well. So what I'm going to do is, what Telecom can do is it can do quite detailed work on this sort of thing. but this will be quite a simple one. These sites are on adjacent channels. So what you're effectively looking at is we're going to start with this one that I've just managed to cover over with the coverage spin, and we're going to look at the effect of having two base stations on adjacent channels, these two, on the coverage of this fella. So what we can do is here under coverage, network interference. Now there's two. In C2I mode you can actually pick up the IRF as well, but we're not going to do that. We'll be simple network interference IRF mode. And on this one, if you press F1, you'll pick up a manual which explains exactly how it all works. There's the screen that you're looking at. So it explains how it all works and everything else, and that will be part of the pack from this demonstration. So this is coverage interference. What we're looking at, the default settings when it pops up. Here we've got coverage, and then there's the sum of the interference plus this thing. It's not noise. It's the channel, adjacent channel. So you've got a 20 or 32 dB attenuation on the adjacent channel, 50 dB attenuation on the next adjacent channel, and you can add more if you want. But that is channel based, so that you've got a 25 kilohertz system. These are 25 kilohertz Nyquist blocks. You can pick up IRFs from ETSI specs, but in order to do that, your systems that you're using here, Telecom needs to know what these actually are. In the case of this one, these are just generic 25 kilohertz, let's say business radio, PMR radio base stations, nothing exciting. So these are Nyquist 25 kilohertz blocks. But if you're doing microwaves or something like that, and you've got the thing defined enough for Telecom to know what it is, it'll pick it up from tables. So in this case, what we're looking at is, let's see, we're doing unwanted to activated first, because I've just happened to have that on there. So this is effectively a plot of the, let's just see, tools palette. Let's just bring on a slightly more intelligent palette if I can find one. Now that didn't work. I did actually load the right one. Okay, well I'm not going to change the colors on it right now, but you can change the colors for the various for these various levels down here. What I was trying to do was to make anything down the bottom end here a different color to the ones that you want. In fact, it is doing it. Yeah, that is the correct palette. So what I'll do is we want to look at this fella here, so I'll just isolate him. That's the easiest way to do this. And if you show his coverage plot, that's the actual coverage plot of the site. And we just want to see what kind of effect these two adjacent channel base stations will do to the actual coverage of this one. And we can go to coverage, get that brain in gear, coverage, interference, IRF. Unwanted are the deactivated sites. So now what we're looking at is we're looking at these two sites here that are slightly offset on frequency. They're deactivated because we don't want them in this plot. Fingers crossed as I flick this button. Right, what that's telling us is that if you get around this particular site here, you're getting quite a significant degradation in this one is adjacent channel. So you're getting quite a significant degradation. It's down here, -23, -38 dB degradation on what you would expect from the coverage of this base station around here, because there's an adjacent channel base station. Over here, this is a next adjacent channel base station. So it's certainly not affecting your coverage so much. But when you get into areas where, for instance, if we go back there, where there isn't a lot of coverage from your base station anyway, this one is definitely beginning to be noticeable. So that's really how you can gauge some kind of let's go in network interference, IRF mode, unwanted deactivated. So you can get some feeling for the kind of degradation you're likely to be getting from base stations that are either not in your network or are in your network. Now the other thing, of course, is that you may wish to deliberately degrade this base station from this base station, and you want to know where you can deliberately degrade it. So that's a useful way of knowing where there's enough degradation for you to be able to program your equipment to perhaps swap from one base station to another at a particular threshold, that sort of thing. But as I say, there are quite detailed instructions on this particular function, and there are at least 3 documents that cover the various features in this. So this is a very simple demonstration just for these purposes, but we'll circulate the documentation on it after the seminar.
Okay, that's lovely. Thanks, Simon. Do we have any questions, anyone? As Simon said, there are several papers that will come out after today's event covering both these subjects, so I'll let you have those by email afterwards. We're also recording today's event, so any of your colleagues that haven't been able to attend will be able to review today's event online afterwards. Okay, I think we're going to go far on to the last question. The last question we've got is regarding point-to-point and point-to-multi-point coverage calculations. Over to you, Simon.
Okay, right. Well, let's just go again, delete everything. Goodbye. I'll just clear my map. All right, here we are. Back in Somerset, chosen specifically because some of the names there are quite funny. Right, what I'm going to do is the scenario here is there is up here in the hills a microwave tower, and this microwave tower is going to be your backhaul for a point-to-point link to one of 3 potential point-to-multipoint sites that are going to be used to pick up data from a cluster of sensors, RTUs, something in this sort of area. So it's a quick, simple point, again for demonstration purposes, point-to-multipoint microwave link and coverage plotting project that deals with everything all in one go. Doesn't go into hopefully any great detail, because as soon as I get into detail, you will still be here on Saturday morning. So what I'll do is I'll just pick up all these sites this time. In fact, I'll just drop them in. Right, so what we've got now is, here is our backhaul site, and what I'm going to do is first I'm going to do a simple plot, just visibility plot for the microwave site. First thing you do, get a feel for, you've got these 3 potential radio sites here that could be used to cover this area, and the idea is to first see whether or not any of those sites will actually see the base station up here. And again, the fastest way to do it is a visibility plot. All these sites have currently got 12-meter antennas, so we'll just do that. And you can see that that site can be seen, this site can be seen, that one can't. So goodbye. So that one's gone. So this is just a quick choose your radio site job. The next thing to do is to decide which one of these 2 sites can see your subscribers, and these are stored as subscribers, these outstations. So I shall go to my subscriber database. They're all selected. Now these subscribers are very simple subscribers. They've got effectively a 12-element Yagi on them. So if I pick up one by default, there's your base station. They haven't got antennas on them at the moment. There's no antenna gain or anything like that, but effectively they're just simple outstations. Their antenna height is actually a bit higher than it should be, but it doesn't matter from this point of view. Hang on a minute, I've just deselected them all. Bring them all back. Make them visible. So we're going to see their location and they'll display a line. So here they are as little black dots. So the next thing to do is to find out which one of these two sites can see these ones. Now you can do it by doing a coverage plot. For instance, for this one, let's see if there's actually any coverage with it. You can do a coverage plot and you can get a feel for it. This one I'm not so sure actually has coverage. No, it doesn't. But one of the things you can do is you can actually get these subscribers to vote for which site they like the best. The best way to do that is they're all there. They've all got antennas on, random type antennas. There are two base stations visible. No need for a coverage plot in this case. So subscriber, global parenting, connect to best server. It's going to go for the strongest base station above the threshold that it's got set. The threshold is very, very low. They're all orphans in that they don't have a parent at the moment, or they would have changed color. So we click OK. And oops, hang on a minute. That one there, let's just, this one has decided he likes the backhaul better. But what I'll do is I shall isolate that one, bring that one in and do it again. Oh, gosh, this is not an orphan now. Subscriber, global parenting. Don't connect just orphans, everybody. So here we go, 8 subscribers on scanner 1, none on scanner 2. Goodo, worked properly that time. So we can get rid of scanner 2 as well. Goodbye. So those two potential sites have gone. We've now got a microwave site up here. We'll be able to talk to that one. We can prove that. We'll have a look here. Profile to scanner 1. And there's the profile of the microwave link. It's a 38 gig link. Little bit of intrusion just here, which is going to affect the reliability. The current power levels are so high that the link parameter margin, it says PSO, which I'm reliably informed means probability of successful operation, but it doesn't. This is the margin over whatever parameters you've set for the microwave link that you're actually getting at the other end. And I haven't really put any great effort into defining the microwave link. It's just a path. After this, you go into detailed planning. But there's a bit of intrusion, so we'll have to lift this end up a bit somehow, which I've already done. But ordinarily, you'd be able to do it from within that path profile. So now so I've lifted it up to 25 meters, and now we've got a clear line of sight. Now all these other lines are just how the path performs as you go along. So there's a curve there in red, which would be the line of sight path if there wasn't any terrain. That's the signal level at line of sight. And this green one is the signal level at ground level. So as you're traveling along the terrain, that's the signal level at ground level. So what you're seeing along the top of these flat bits is areas where you are line of sight with the base station. So there's only very little attenuation. But you get big dips. If you go down here, you lose the base station altogether. And as you go back up again, the signal comes back up. If the signal doesn't come back up, you're using a coordination propagation algorithm like 1546 or something like that, which is utterly inappropriate for this sort of work. That's for coordination work. You wouldn't want to use it for detailed radio planning. So there's your path profiles, and of course what we'll do now is we'll just link that one way to there, and you might be able to just see a little dotted line on the map. So there's a bit of linking going on. You could convert those into a microwave link now, but that's the project built. Nice easy one, but that's the project built. It covers most things, I think. Coverage plotting. Let's just do a quick coverage plot for the scanner, just to prove that you can. Coverage calculation. Height of receive antennas is set to 6 meters. Although these outstations are all at 12, so I'll give it 12 meters. 12 is very high for an RTU. 20 or 35 kilometers. We'll leave the thresholds alone in this case. The model being used is 525526 version 13, which picks up a Delta Bullington diffraction geometry by default. It's probably the go-to model that you would use for pretty much everything. There are more specialist ones, but for general coverage plotting like this, that's fine. Just press OK, and it will do a calculation spin. And what it's doing is it's every pixel on this map. It's calculating the path loss and the attenuations and everything according to 1546. So this is why it's quite slow. If you were trying to do this with a 1 meter LiDAR map, it would probably still be on the first part of the spin by now. It's quite labor intensive. We'll just finish that. So that's the coverage plot, and as you can see, all the outstations are actually in nicely covered by this base station, not a lot in between. But for point to multipoint, generally speaking, you don't do coverage plots. It's not really necessary. It's multiple fixed links, and you're really dealing with path loss between these 2 points, and you're not really interested in whether or not there's any coverage in between, unless you've got a lot of points and you just want to get a feel for the kind of coverage that base station has got. Generally speaking, coverage isn't necessary.
Okay.
There you go. I think that sort of covers it.
Super. Do we have any questions from that subject? So that's point to multi-point calculations, coverage calculations. If you have got any questions, pop your hands up. Okay, Simon, we did have a couple of questions come in from the other subjects that we covered. So if we can go back to creating a DTM in ICS Manager. We had a question come in, can I use SRTM data?
Yes, you can. But I don't have any SRTM data to demonstrate with. But yes, you can. It's similar. You can do it from, I think it's actually, you can import it. Oh yes, of course, yeah. Brain gone. Here we are. For some reason or other, it's an outdoor project, and you can bring it in from SRTM there. I don't want to keep that. And here we've got the RCASCII file, and if I had one, I could import it, and that brings it out into a project. So you can actually bring them in at that point, and there's various converters here. But as I say, I haven't got any SRTM to demonstrate with at this point in time. And you do need a lot of the time an account or login to pick it up, which I don't have at this point. But yes, perfectly possible to do so.
Excellent. Okay, that's great. I'm assuming when you mean by an account and a login, you mean to the Worldwide Builder.
Yes, or directly from the USGS website, which this will do.
Excellent. Okay. I hope that answers your question, Steve. Yeah, it does. That's lovely. Thank you for that, Simon. We've got another one. We can go back to the subject we covered on IRF and NFDs. The question is it possible to download NFD files or any other additional information, or do I have to build the NFD file myself?
I'm not sure actually. I can just ask a colleague just to
okay,
just
so
to be sure.
An answer I did have from another colleague who's just popped that up says you do need to build them yourself. The IRF calculator is an inbuilt tool in ICS Telecom to assist with the production of NFDs. You just need the transmitter and the receiver information as an input, characteristics as an input.
I should think if we dig up the documentation for that, it will explain all that.
Okay, so yes, you do need to build them yourself. IRF calculator, which is integral to ICS Telecom, will help with assisting producing the NFDs. You just need the transmitter and the receiver characteristics as an input. I hope that answers your question, Vasil. Okay, I hope it does. If not, we can take this offline. Do we have any other questions today on any of the subjects we covered? Okay, while we're waiting for those questions to pop in, and you know, by all means do use that toolbar or put your hand up and I'll open the audio up so you can talk to Simon directly. Just a couple of follow-up things. Today's event has been recorded and the recording will be made available to you. I'll send you the link via email. If you want to distribute that to your organisation, please feel free. The whole idea with these events are they are very low key, so we tend not to put them up on the website, but they will be available via our YouTube channel. Our next event is due to be held on Friday the 1st of September and you will receive an early bird invitation for that at the end of today's event. Please do sign up. We tend to try and keep these as small as possible just purely because it makes it easier. So next event Friday the 1st of September. I'll also be looking for some feedback from today's event, so that's a questionnaire. If you could please complete that, that would be great. It'll take 2 minutes of your time. Key points for us here is firstly to understand whether today's event was useful to you, and also so that we can help develop future events. So that subjects for future events are always helpful, points us in the right direction and make sure that we're talking about the things you really want to hear about. Okay, just one last call for any questions, otherwise we'll call today's event to an end. Any other questions, anyone?
Just one thing. Remember to press the F1 key when you come up with something that you're not sure about, because we're all working very hard putting the documentation into this system at the moment. So it might not have worked last week, but it might work this week.
Okay, that's great. Thanks for that reminder, Simon. Just one very last reminder about future events. We have an ICS Telecom EV Masterclass next week. So that's for any existing users or new customers that are interested in the release of ICS Telecom. This is a totally new product. There's a direct migration line for existing users of ICS Designer and ICS Telecom to the new product, and this masterclass is aimed at giving you the first view into what the new product looks like, so you get a good look and feel of features, functions, and a new user interface. If I will be sending you a link to that so you can register today if you've not already done so. Okay, I'd like to take this opportunity to say thanks to Simon for joining us today. Thank you, Simon. And we look forward to joining you all again shortly. Next week if you can, if not on the 1st of September. Thanks everyone. Have a really great day.